When we talk about preterm birth, meaning babies born before 37 weeks, most people think about the early physical challenges. But there's this whole hidden side involving long-term brain development. It's fascinating, and honestly, a bit unsettling, how those first weeks outside the womb can shape a child's cognitive abilities for years to come.
What really gets me is how even moderate prematurity, not just the most extreme cases, can leave a mark on how the brain develops and functions. For example, the study we're diving into today actually compared kids born very preterm, moderately preterm, and full term, and they found some pretty striking differences in cognitive performance as these kids hit 9 or 10 years old.
Yeah, the numbers were kind of eye-opening. Almost 30% of very preterm kids had low cognitive performance, and even among moderately preterm kids, about a quarter struggled. That's a lot higher than the full-term group. But what's especially interesting is that these issues tie back to actual brain changes, not just test scores.
Exactly. Brain scans in the study showed that the kids with lower cognitive scores had specific changes. For very preterm kids, it was thinner regions like the inferior temporal cortex and fusiform gyrus, and even a bigger amygdala. For moderately preterm kids, the hippocampus was smaller. These aren't just random findings, they're areas crucial for things like memory, attention, and even social processing.
That actually reminds me one thing I always wonder is why some preterm kids do just fine cognitively, while others really struggle. It's not like being born early automatically means problems for everyone.
I've wondered about that too. The study authors pointed out that it's not a one-size-fits-all story. Even among preterm kids, there's a ton of variability. Some of it seems to come down to which brain regions are most affected and how the rest of the brain tries to compensate, like certain networks might strengthen to make up for weaker connections elsewhere.
So maybe a kid with a thinner fusiform gyrus has trouble with visual memory. But if other brain areas step up, they might not show big deficits on cognitive tests. It's almost like the brain tries to reroute traffic when there's a roadblock.
Totally. There's a bit of a silver lining there. The study even found that in moderately preterm kids with cognitive difficulties, some brain regions actually work together more strongly. That stronger connection, especially between the precuneus and postcentral gyrus, could be a compensatory trick, although it doesn't always fully solve the problem.
Funny you say that, because this idea of compensation leads right into the link with developmental conditions like ADHD or autism. The researchers checked if the unique brain connection patterns they saw at age 9 or 10 could predict symptoms by age 12.
And while the associations weren't statistically significant, there was this trend: kids with stronger connections in those brain areas sometimes had a bit more in the way of ASD or ADHD traits later on. It's not enough to make firm predictions yet, but it hints that early brain changes might set the stage for later behavior and learning issues.
It feels like we're only starting to scratch the surface of how early disruptions ripple out over time. I mean, thinking about interventions, should we be looking at brain scans and tailoring support based on these neural patterns instead of just waiting for test scores to reveal problems?
That's actually where the authors landed, too. They argued that these differences in brain structure and connectivity suggest the need for more personalized, prematurity-aware interventions, maybe even before major learning difficulties pop up. It really could change how we approach support for preterm kids.
So, big picture, what's the takeaway here? We're seeing that cognitive struggles after preterm birth aren't just about being born early, but about which brain systems are disrupted and how individual brains adapt or don't.
Absolutely, and I think it's important to remember that these findings aren't set in stone. There are still a lot of open questions like what role genetics play or how early life experiences and family environment might help some kids bounce back. The key is we're moving towards understanding preterm development in a much more nuanced way.
And hopefully, with more research like this, doctors and educators can spot at-risk kids earlier and offer the right kind of help tailored to their unique neural profiles instead of waiting for problems to snowball.
Exactly. It's a tough road for some children and families, but with science zeroing in on the details, there's real hope for better individualized support in the years ahead.